Let's see, lesson 5. So we're going to talk about ionic compounds today and how they are formed. So we're going to have a few notes here. Formation of ions, basically, and then we're going to talk a little bit about how they transfer electrons to each other. We'll show you that real quick. We'll let you copy, and I'll be quiet. So formations of ions. Why do we get ions? We get ions because, of course, atoms want to gain and lose electrons to have a full outside energy level, right? They want to have 8 electrons in the outside energy level. They do that by, of course, gaining and losing electrons, sometimes sharing, but we'll talk about that down the road. Today we're focused on ionic compounds. So they do this through gaining and losing electrons, and that's how they get their full outside energy level. That's how they become more stable, right? When neutral atoms which do not have a full valence level come close enough together, one or more electrons may be transferred from one atom to another. We know that the metals lose electrons, yes, and the nonmetals will gain those electrons, correct? All right, moving on. Here's an example, sodium and chlorine. So we're going to write this out together here. Sodium. We're going to do a little electron energy level diagram just for a little practice, okay, which could be our next quiz, I guess, roughly. 11 protons. 12 neutrons, right? Symbol, nucleus. First energy level would have 2, 8 in the second, 1 in the third, right? And of course, sodium. This is the sodium atom. So one of these days we'll go to the lab or we'll go outside or something, I'm not sure, and we'll show you some sodium when I cut it. This is neutral sodium, no charge, 11 positives. 2, 8, and 1, get a calculator. 11 negatives. So 11 positives, 11 negatives. This is sodium atom. Okay, and in fact, that's what we call it. We call it the sodium atom. Okay, make sure you write this down. Chlorine. Okay, chlorine looks a little something like this here. And of course, we're going to call this the chlorine atom. Chlorine has what? 17 protons. 18 neutrons. I guess that was part of your quiz today, yes? How many protons, neutrons, right? This has a weight of 35.45, 35. So that's where the weight comes from, is the nucleus. We have 2, 8, and 7, yes? Looks like that. And when these atoms come close enough together, what they want to do is help each other out become more stable, right? So to do that, they come close enough together. When this gets close enough to this here, basically when these two atoms come close enough together, there will be a transfer of electrons. Basically, chlorine says, hey, I need an extra electron. Sodium's like, I really don't want my extra electron. So they kind of work together to help each other out. So there is a transfer of electrons. Okay. Basically, now what we end up with is sodium, which looks like this, 11 protons, 12 neutrons, 2, 8. Okay, we kind of chop it off right there now, right? That one electron has moved over to chlorine, right? So we get kind of something that looks like that. But what's the overall charge now on sodium here? Don't all answer at once. It's okay. The overall charge here, get a calculator if you're confused. 11 positives, 10 negatives. What's the overall charge? Huh? Nope. +1, okay? So +1, yes? Sodium becomes what we call an ion, yes? And in fact, in this case here, we're going to call it sodium ion, okay? So we have 11 positives, right? We have 10 negatives. 11 positives right here, nucleus, 10 negatives right there, right? So 11 positives, 11 negatives. Overall, it's a 1+, right? And that's how we get the sodium ion. This has now become more stable because we have 8 electrons in the outside energy level, right? 2, 8. That's it. Chlorine had 17 protons, 18 neutrons, had 2, 8. It had 7 right here. It did have 7, but remember, this electron right here has moved over, right? So we actually have 8 right here now. And again, now it's more stable as well, correct? Okay, it's got 8 electrons. This is what we call the octet rule. and it's got 8 electrons in the outside energy level, and it's become more stable as well. They've helped each other out become more stable. And again, if we add up the positives, there's 17 positives. That's 8, and 8 is 8, or sorry, that's 10 to 8, and 8 is 18, yes? So 18 negatives, 17 positives, we get a Cl with a 1 minus charge, right? And of course, we don't call this chlorine anymore, we call it chloride, right? So we drop the ending and we put on the ide instead. Okay, chloride ion. Good? Okay, questions, anyone? Yeah. Yeah. Questions? Here are some Lewis diagrams, if you remember. Yes? Okay. I'm not too concerned. You don't have to copy this because we're going to do this again in lesson, what are we, 5 now? So 7, I think, is when we're going to do this. But we're going to show you how, basically using what we call electron dot diagrams or Lewis diagrams, how sodium and chlorine come together. Okay, remember, so Lewis diagrams only include valence electrons. So we just talked about sodium chloride, right? Here's that 1 valence electron that we just talked about, that 1 in the outside energy level, 2, 8, and 1. And it moves over to fill in, basically, this missing spot right there, yes? Okay, and then we put some brackets, which we'll talk about, and some charges in there as well, okay? Magnesium has 2 valence electrons, so it needs to lose 2 valence electrons. Oxygen has room for 2 valence electrons. So 1 can go here to fill up that, and 1 can go here. If you remember, in the outside energy level, oxygen has 6, 2, and then 6, right? So for a total of 8. So in this case, oxygen can gain another 2 to make that octet, and that's how they help each other out. And it doesn't have to be perfect, of course. We know that when we get to naming ionic compounds, we might have to have magnesium loses 2 and chloride only gains 1, so we have a way to do that, which is swap and drop and naming ionic compounds and all that stuff, which we're going to do shortly here. But good? Questions? Okay, so we're just going to skip that, but remember, the metals lose electrons, okay? We know those as cations, which we're going to talk about in a second here, and then nonmetals will gain those, which we call anions, yes? And I think that's coming up in the notes right here. So I'm going to get you to copy. We don't need to copy this. Don't worry about that. I think, yeah, the rest I think we shall copy here. Definition of ions, and then what the metal atoms are called, and names, how you name that. So let's copy that maybe. Okay, so ions are atoms that have electrical charge because they've either gained or lost electrons. When metals lose electrons, because that's what they do, metals lose electrons, they are known as cations by losing valence electrons. To name a cation, we just basically call it what it is. So if it was calcium, we call it calcium, and we just put the word ion behind it. Okay, sodium ion, potassium ion, whatever the case might be. I know what you're thinking. If metal atoms are cations, non-metal ions should be dog ions. Cations and dog ions, because they're opposite of one another. Get it? Okay. Cations and anions, of course, yes. That was funny, but if I got to keep explaining all this, it's going to be not good. Okay, there's the rest. So for nonmetals, they form negative ions, also known as anions, and they gain valence electrons to fill their outside energy level. We drop the ending, we put the word ide on, especially with obviously the, bromine becomes bromide, chlorine, chloride, sulfur becomes sulfide, et cetera, et cetera. All right. You're gonna have to copy this as well. We're gonna briefly talk about polyatomic ions. And they are cations and anions that are made up of a group of atoms. So a group of atoms come together, and they may gain a positive charge or a negative charge in some way. They mostly end in ate or ite, right? And we're going to do a couple of examples here. So polyatomic ions. Polyatomic ions. there is, you're going to get periodic tables out. Periodic table out. Now, in the top left of your periodic table, in that little square up there, of course, right above all the elements there, most of the metals, you're going to have a list of polyatomic ions there. Those are the most common ones, of course, and we're going to go through a few, but we're going to learn something new today, hopefully. You know this chart from last year, correct? Things like, I don't know, nitrate, sulfate. You remember those from last? Carbonate. We're going to learn a few new ones this year, okay? So, a couple new ones here, but before we get to that, I guess, most of them end in ate or ite. Ite? That's a gangster thing. You wouldn't understand. All right. And most of them end in ate or ite, but there's a few exceptions. Well, not a few exceptions, I guess, but we need to be able to kind of fill in all these things here. Okay, so I'm going to get you right now, just in your notes here. I want you to copy down those 4, and notice it's NO4 with a 1 minus charge, NO3 with a 1 minus charge, NO2 1 minus, and NO 1 minus. Okay, don't worry about this less oxygen thing here. Don't worry about that. Just notice that the charges all stay the same. Charges are the same. We're just gaining and losing oxygens, depending on however you want to look at that. Okay. So we're just gaining and losing oxygens. That's it. So don't worry too much about this one less oxygen here. All the same charge, 1 minus, but just a different number of oxygens, polyatomic ions. Go to your polyatomic chart there, or your periodic table, and I want you to find whichever ones you can here. Which ones can you find on this chart? Which one? Somebody over here. Sure, Kaylin. Okay, what's NO3 1 minus called? Nitrate. Okay. And what about NO2 1 minus? What's that called? Nitrite. Okay. Now, I don't think that's I don't think that's new for you, but maybe it is. Okay, that's what we did. I assume in grade 10 science. Okay. However, grade 11 chemistry, we're going to talk a little bit about what about these other 2. You're not going to find them on the list. Okay, they're not there. However, they always follow a pattern. Okay, so if this is nitrate, which happens to be NO3 1 minus, if I add another oxygen, notice the only thing that changes is the number of oxygens. So now I add one more oxygen. This is called always per nitrate. Okay, so we put the prefix, I guess you want to call it, per in front of there. So that's called per nitrate. Okay. And at the bottom here, we have nitrite. If we lose another oxygen, so if we take off an oxygen, this down here is called hyponitrite. So still kind of keeping in consistency with that. Most of them have ites and ates for endings, but we have to put on these little prefixes here to adjust for the number of oxygens. These are called what we call, fancy term for this is called oxygenated, because oxygens, oxygenated polyatomic ions. Okay, so that's the case for most of those on there. So let's do another one here. Let's take a look at this one here. Let's start with SO5, and that's a 2 minus, SO4, 2 minus, SO3, 2 minus, and SO2, 2 minus. Okay. So when you're done copying those down, again, the charge stays the same, 2 minus for each one of these, SO5, SO4, SO3, SO2, all with a 2 minus charge. Go ahead and find whichever ones you can on the periodic table there, then polyatomic list, write them down, we'll go from there. Okay, which one can you find in that list there, that polyatomic ion list? Yeah, Tyler? Sulfite, that's, which one is that? Okay, so this is sulfite, okay? SO3 2 minus is what happens by the bike racks after school, if anybody makes fun of asking questions in this class. SO3 2 minus by the bike racks. Think about it. Sulfite. Tough crowd today. I see. Long weekend. We forgot all my good jokes. Well, let's go. I got another one for you right away here. SO3 2 minus sulfite. Let's sulfite. If you buy the bike racks after school. Oh my gosh. Not funny, apparently. Okay. What other ones? Any other ones? Yeah. Sulfate. I don't have a joke for that one. Sulfate. Okay. Now that I know those two, or even if I just knew one, you know, even if I just knew, let's back that up. Let's say I didn't even know that. If I know that one, then I know the rest of them, okay, because they always follow the same pattern. So if that's sulfate, one more oxygen is if this is sulfite, this has to be sulfate. This has to be per sulfate, okay, per sulfate. And likewise at the bottom, if that's sulfite, okay, this has to be hyposulfite. Good? Always follows that same pattern. Now, I do these two examples for a reason. The one thing you cannot do, so what it depends on is what's on the periodic table. My point is this, okay? If SO4 is sulfate, well, that's for that one. Sulfate is SO4 2 minus. Nitrate is NO3. So just because it ends in 8 doesn't mean there's 4 oxygens or 3 oxygens. It really depends on what you can find on the periodic table, if that makes sense. Whatever you find, that's what it's all based on, all right? So it just depends. Like phosphate, PO4 is phosphate. Carbonate is CO3, but it depends on what you can find on the periodic table. If you forget, you don't have to copy these down, but if you forget, this list is for you, and then actually right here, that's just the opposite of that, right? Those are the same thing. In case you forget, if you look in that list, okay, that square, look in the bottom left of that square. You're going to come across these 4 here, okay? And these 4 start with, of course, perchlorate, chlorate, chlorite, hypochlorite. That's how it works. So that kind of example is there for you in that list, but you have to know how to adjust it accordingly. All right, that'll be tomorrow. That'll come into play a little bit more probably tomorrow worksheet, but that's what we're talking about there. All right, questions, anyone? So again, it just depends on what you find. In this case, this was chlorate, perchlorate, chlorate, chlorite, hypochlorite. Okay, and by the way, those are chlorines there, CLs. There's no such thing as, well, there's no CiO3. Those are CLs. Chlorine, chlorate. Good. All right, moving on. Next. Ionic compounds. I don't know. Do we need to write all this out? I think we know that. I think the most important thing here is that, of course, and I think you know this, so I don't think we need to. If you want to just jot down a few quick things, that's up to you, I guess. But we know that ionic compounds are made up of the simultaneous attraction between positives and negatives, yes? Cations and anions. So positive ions and negative ions. That's what holds them together, yes? That's what holds them in. Actually, what shape do they form? Do you remember from Science 10? It's a cubey looking thing. What's that? What do we call that? What shape? Come on, Science 10, you should know this. What? I don't think so. How about a CR? Yes, which is an alternating three-dimensional array of positives and negatives. We're going to look at that again this year, crystal lattice. They always take on that shape, plus minus, plus minus, plus minus. It's magnets. That's how they're attracted to it. That it turns out is really good, strong, right? They stick together really well. The sum of those positives and negatives has to be 0. That's the key, right? Overall, they're neutral. And we always write the metal first and then the non-metal second. All right, so I don't know if you need to copy all that. I guess the most important thing is, of course, the sum has to always equal 0. That's how we get swap and drop, of course, if you remember that term, right? Somebody told me last year that they didn't do swap and drop. They didn't really talk about swap and drop. Well, we'll do that this year, but I'll also show you a few different options for that. But ultimately, it's the same kind of idea. All right, questions? Yep. Oh. All right, Icp Preview. Ready? Here we go. So you can just copy these ones down. We'll just do this real quick. And we got a few other examples here, and then I'll be quiet. Sodium ions and chloride ions, of course, Na1 plus and Cl minus. Let's just do this part here. This would be called the sodium ion. This is the chloride ion. Okay, obviously together we'd call it sodium chloride. We are going to do swap and drop, or if some of you remember, we did this example at the beginning of class, if you remember. Sodium loses 1 electron. Chlorine gains 1 electron to become chloride. And of course, if you remember from last year, we did a little swap and drop, yes? So maybe perhaps 1 comes over, 1 comes over. We don't write the 1s because we don't write 1s, okay? So that's the formula there, of course, and this would be called sodium chloride. I don't know if you want to write that down or not, but this is sodium chloride, all right? If we're going to combine, this is here, and if, again, it's been a while for some of you since Science 10, so if you forget what these are, this is aluminum, of course, the aluminum ion, technically. So aluminum and chloride. And again, what I would do is I usually just start with that, and then I do the swap and drop. We'll talk about where swap and drop comes from for a second here, but here comes the 3. The 3 comes over and down, so I'm going to put a 3 here. The 1 comes over and down, but I don't write the 1. This is called aluminum chloride, right? Correct? All right. So, a couple things with this one before we get too far here. Now remember, where does swap and drop come from? It comes from the fact that, you know, we're dealing with these 2 ions. Well, do these 2 at this point, do they cancel each other out? Remember, the whole point of ionic compounds is whatever I lose has to be what it's gained, so the overall charge is what? 0. Is the charge, overall charge here 0? No. What about now? Is the overall charge 0? What about now? 3 plus, 3 minuses, yes? Neutral. That's where swap and drop comes from. So I know some teachers explain it this way. That's fine. Okay, but that's where swap and drop, that's what a swap and drop is, basically. Okay, so that's what we get there. This would be called aluminum chloride, of course. Like so. All right. Yeah. Well, that's the 2 ions that are involved, yes. Yeah, up here or here? Yes, right here. Yeah. Okay, aluminum, which comes in a 3 plus, and again, you can find this on the periodic table. O comes in a 2 minus. I guess I don't need to write that over again. But again, what I would do is probably something like that to start with. The 3 is going to come over and down, like so. 2 comes over and down. There's the 2. And this is called aluminum oxide. We do not, as you remember from last year, hopefully, whenever that was, we do not use prefixes because there is only one possible combination to give you 0, right? It's not like we can take, you know, in this one here, it's not like I can use right here That's the only combination that's going to give me 0. Yes, the whole lowest, I guess, whole number combination, right? If I have a 3 plus and I have Cl1 minus, I don't need to tell you how many of each one because I need 3 to go with that 1. That's how it works. So we don't use prefixes here, right? That's molecular. That's different. We're not there. So we do not need prefixes for any of these. They only combine together in one ratio where the overall outcome is 0, neutral. All right, good. Moving on. Yes. All right. Polyatomic ions. I will get you to copy this just because we do need to remember that sometimes we need brackets. Brackets have to be used at times. So I'll let you copy this here and then I'll be close. All right, so in this case here, when we're dealing with polyatomic ions, we find those in the top left like we kind of did before. And in this case here, I'd again probably write out that and that, of course, to start with, and then use the charges to swap and drop or think about how many of each one I would need. The 1 is going to come over and down is what I would usually say is the 1 comes there. I don't write the 1. 2 comes over and down right here, and I would put that in there, of course. This is known as lithium because we're dealing with the lithium ion, so this is lithium. And CO3 with the 2 minus charge, we just looked that up on the polyatomic list, and that's carbonate. So this would be carbonate. All right. This one here. Now, this one we probably don't do a lot of. It's been a while probably, but NH4 1 plus is actually, and again, sorry, I don't know if I mentioned this, but the polyatomic list is based on alphabet. Okay. So ammonium is actually one of the only ones that you know of so far. That's what this is. It's a little different than ammonia, NH3. This is ammonium, NH4. Again, if I'm going to start with that and then do the swap and drop and reduce if I need to, which we'll talk about in a little bit. 1's going to come over and down. I don't write that. The 2 comes over and down here. So the 2 goes here. But does that look right to you even? No, you can't just put a 2 there, right? So we're going to need some brackets here, right? Anytime you're going to use a subscript, so 2, 3, 4, with a polyatomic ion, not ones you don't have to worry about ever, but 2, 3, 4 with one of those from the top left there, that list, polyatomic ions, you want to use brackets. The other way to think about this is, by the way, this is called ammonium. It's the very first one in your list, and this is S2 minus, so sulfide, ammonium sulfide. And basically, once again, nitrogen and 4 hydrogens have combined together. We're going to look at this later on, and we're going to understand why. When you combine nitrogen and 4 hydrogens, we need to get rid of an electron. There's a reason for that. We're going to draw this later on. So it needs to get rid of 1 electron. All right. Sulfur, we know, wants to gain 2 because it's got 6 in the outside shell. So it wants to gain those extra 2 to become more stable. Again, you have to ask yourself, do these 2 cancel each other out right now? The answer is no. How am I going to get that to happen? I need 2 of those, right? All of that together. I need 1 to lose 1. So I need NH4 to lose 1 electron. I need another NH4 to lose another electron so that S can gain those 2 electrons. That's why we need to have brackets there. It's not just the H or the N that needs to gain or lose an electron. It's the whole group of those atoms that need to lose an electron. So that's why we end up with that. That's why we need to have brackets. Same thing here. This is NH4 and CO3. Again, 1 comes over and down. Don't need to worry about it. It's 1. 2 comes over and down. I'm probably going to have to put some brackets here, right? 2, 3, 4. Brackets, all right? This, of course, is called, and again, ammonium. And then CO3 is, we know from before, up a little bit here, that's carbonate. Okay. So that's known as ammonium carbonate. Questions, anyone? And it's going to take a while because you're going to see some different ones this year. So we're going to use things like scandium and titanium and chromium and manganese and niobium, you know, just to make tungsten, which is actually W, right? Things like that. So you might have to go on a little scavenger hunt. It'll be fun, right? Good. A couple more examples here. All I need you to write down here is multivalent. Multivalent metals, basically. Multivalent. And let's just take a look at these two examples right here. I'll let you copy that here. Multivalent metals, and I'll give you just those two right there for. What is a multivalent metal? Remind me again, somebody. Anyone, please help me out here. What's multivalent? What does that mean? You should know because we took it last day. Sure, go ahead. Has more than one charge. Where do you find the more than one charges? Where do you find them? Yeah, whereabouts? Because this is a kind of a common thing with a specific thing there. Yep. Yeah, but generally speaking, just generally speaking, where do you find them? Sorry, what? Yes, but just generally, yeah, you're all right. Yeah, just not asking the right question. What group do you usually find these in? That's, I guess, what I'm trying to say. Maybe that's, yeah. Huh? Sorry. Yeah. More specifically. Sorry. Speak up. Yell it out. What are they called? Transition metals, right? Groups 3 to 12. So when you're dealing with things in 3 to 12 there, right? Transition metals, which you know should, because we took that on what? Friday? Yes. Yes, Friday. Transition metals, 3 to 12, right? That's what, and it says, right, as one of the lists there, you should be studying every night, by the way. I'm going to catch up to you eventually here, trust me. 3 to 12 are the transition metals. They're one of their properties is they can have more than one charge. For example, iron is in there, right? So here we have iron. By the way, this is called iron. How do I represent the 2 again? Who remembers? Yep. Roman numerals. Iron 2. Okay. And in fact, by the way, that's called the iron 2 ion. And this is, of course, iron 3 ion. These two both involve iron, and they both involve oxygen. The transfer electrons, these have very different chemical properties, though. So we need to be specific, iron 2 or iron 3. Now, this is, of course, oxygen with a charge, so that's oxide, right? But if I swap and drop these two here, iron 2 plus and O2 minus, look, if iron loses 2 electrons, if this loses 2, there's iron right here, and here's oxygen, it takes 2, how many do I need of each to make it neutral? This loses 2, this gains 2. I only need 1 and 1, yes? Right? This one loses 2, this takes in 2. So 2 plus can come over 2 minus, but we're going to swap, drop, and reduce, right? So instead of 2 and 2, we'd use 1 and 1 with the charges, right? This one loses 2. Look, just look at that. Look at those 2 right there. 2 plus, 2 minus, that's neutral, yes? 1 and 1, okay? Now 1 loses 2, that one gains 2. This one, on the other hand, though, if we're going to swap and drop, 3 comes over and down, boom. The 2 comes over and down, boom, okay? And again, these have very different physical properties, have different molar masses, okay, which we're going to talk about. And you remember molar masses from Science 10? This one would have 1 iron and 1 oxygen. This has 2 irons and 3 oxygens. Very different molar masses, yep. Yeah, so this one's called iron 2 oxide. And the only difference is this one is called iron 3 oxide. And those are the 2 different names that we would name those. Anytime you have something from 3 to 12, those transition metals, you better probably double check, because there's a pretty good chance that there's more than one charge there. Okay, chromium has 2 charges, titanium, cobalt, copper, nickel, silver doesn't, cadmium does. Yeah, so lots of them have more than one charge. Right, good? Questions, anyone? Sure? Okay, I think we're stopping there. Let me just double, yeah. This is going to be your homework here. I'm going to give you this sheet right away. We're only going to do the first 5 rows just because I want to just kind of get a sense of how things are going. And then tomorrow, I'm hoping, I don't need to record this,